In this tutorial, let us check how to draw the cycloid. Here we see the definition of a cycloid. The definition is when a circle rolls along a straight line without slipping, the curve traced by a point on the circumference of the circle is known as cycloid. There are two important things. One is the circle that rolls along a straight line. The circle is the generating circle. As the generating circle rolls, a curve is traced, and this generating circle rolls on a straight line, and this straight line is known as the directing line, and hence there are two entities. One is the generating circle, which is in red color, and a straight line known as the directing line, also called as the baseline, which would be in violet color. So here in question, the diameter of the circle might be given, or the radius of the circle may be given. The generating circle, the radius is given as 25 millimeters, and if diameter is given, then the radius would be half of the diameter. And when the generating circle rolls upon a straight line called as the directing line, also called as the baseline, then the distance covered would be equal to the circumference of the circle, and hence the baseline length, which is also same as length of the directing line, is nothing but the circumference of the generating circle, and is given by the formula 2 pi r, where 2 into pi into r is 25 mm, and hence we get 157 mm in this case. Now to draw the cycloid, we require to draw the generating circle, which is denoted here in red color. So this one is the generating circle. First we need to draw a circle of radius 25 mm. Now this circle has to be divided into 8 equal parts. So here a vertical line is drawn through the center of the circle, and then a horizontal line is drawn using the drafter. And from the center of the circle at 45 degrees, two more lines are drawn. Now we see that the circle, the generating circle, has been divided into 8 equal parts, and now each part shall be marked. So here marking is done, and these marking are done in red color. 1 2 3 4 5 6 7 and 8, these points which are drawn on the generating circle, these red color points are known as circle points. Now once the circle is drawn and divided into 8 equal parts, now at the bottom, that is the 8th point, so from that point the baseline or the directing line is drawn. This is the directing line, also called as the baseline. Now the length that has to be cut off from this directing line is 157 mm, and hence at a distance of 157 mm a point is marked and the dimensioning is done, and this length is 157 mm. Now this length of 157 mm has to be divided into 8 equal parts. Division of a straight line is already known, so now I divide this into 8 equal parts. So these points denote the 8 equal parts on the baseline, and the numbering has to be done from 0, 1, 2, 3, so on. So these numbers which are done on the baseline in violet color are known as base points. Now once the generating circle and the baseline or the directing line is done and the points are marked, next we need to draw the locus lines. Now the locus line has to be drawn from the circle point 7 and 1, a line passing through the circle points 7 and 1 is the locus line of 7, 1, and it is denoted in brackets 1, 7, and then another line has to be drawn passing through circle points 6, 2, and this is denoted with 2, 6. This particular line is also the locus of the center point of the circle, and hence this line is denoted here in black color, and we also write locus of the center, because as the circle moves, the center of the circle moves along this line, and hence this line is locus of circle point 2, 6 as well as locus of the center. Next we need to draw the locus line passing through the circle points 5 and 3, and at the end in brackets 3, 5 is noted. Now the last locus line passing through the circle point 4 has to be drawn, and this is the locus line, and in brackets 4 is marked. So once the locus lines are done, next we draw the center points. Now the base points in violet color are present. So from the point base point 1, we draw a vertical line cutting the black line, the locus of center, and we get a center point C1. Similarly, from the base point 2, a vertical line is drawn and it cuts the center line at the point C2, and from the base point 3 we get the corresponding point C3. From the base point 4, a vertical line is drawn and the point C4 is marked. Similarly, from the point 5 we get C5, from the point 6 we get C6, from the point 7 we get C7, and from the point 8 we mark C8, a vertical line drawn from the base point towards the center line. Now that we have the center points, next we need to find out the points for the cycloid, to draw the cycloid. So from the center C1 and radius of generating circle, that is 25 mm in this case, an arc is drawn cutting the locus of 1, 7 towards the left. So here an arc is drawn and the point is marked as P1. Now with the center C2 and radius 25 mm, an arc is drawn cutting the locus 2, 6. In this case it is the black line, and the arc is cut at the left and the point is marked as P2. Now with center C3 and radius 25 mm, an arc is drawn to cut the locus line 3, 5 towards the left, and the point is marked as P3. Now with radius 25 mm and center point C4, an arc is drawn either to cut or to touch the locus line passing through the generating point 4, and the point is marked as P4. Now with center C5 and radius 25 mm, an arc is drawn to cut the locus 3, 5 towards the right, and the point is marked as P5. With the center C6 and radius of the generating circle 25 mm, another arc is drawn to cut the locus 2, 6 towards the right, and this point is marked as P6. Now with C7 as the center, radius equal to 25 mm, an arc is drawn to cut the locus line 1, 7 towards the right, and the point is marked as P7. And finally P8 matches with the base point 8. Now that we have all the 8 points P1, P2, P3, P4, P5, P6, P7 and P8, a freehand curve has to be drawn passing through all these points, starting with the base point 0, and then with P1, P2, a freehand curve is drawn, and this curve that passes through the points P1, P2, P3, P4. This curve is known as the cycloid, and hence in this way we can draw the cycloid. Now, once the cycloid is done, the next part is to draw the normal and tangent at a point on the cycloid. Now let's try to draw the tangent and normal. The given question is draw a tangent and normal to the curve at a point 40 mm from the directing line. Here the definition is given. Normal at a point is the line passing through that point and its corresponding base point on the baseline. For example, let us take the point P3. Here P3 is on the cycloid. Now the point P3 has its corresponding center C3, and when we move down from C3 we have a base point 3 in the violet color, and therefore point P3 has a base point 3. When we join the point P3 with its base point 3, here the green color line joining the point P3 with the base point 3 denotes the normal. If we draw another line passing through the point P3 but perpendicular to this normal, that line would be the tangent, and in this case it is the deep blue color line. And in this way we can first draw the normal, and then perpendicular to the normal passing through that point we can draw the tangent. Now in the given question the point has to be 40 mm above the directing line, from the directing line. So first we need to mark a point which is at a height of 40 mm from the directing line. So here we mark a point which is at a distance of 40 mm from the directing line. Now from this point we draw a locus to cut the cycloid. And here the locus cuts the cycloid at a particular point and it is marked with P. So here the point P is on the cycloid and it is at a height of 40 mm from the directing line. Now from the point P with a radius of the generating circle, in this case 25 mm, we cut an arc on the center line. So with a radius of 25 mm, an arc is cut on the center line, and that point is the center point for the point P. For the point P, it is the corresponding center point and it is marked with the letter C. Now from C a vertical line is drawn towards the directing line, or a vertical line is drawn towards the baseline, and this vertical line cuts the baseline at the point known as the base point, denoted by capital B. So for the point P, which is on the cycloid 40 mm above the directing line, its corresponding base point is capital B. Now when we join the 2 points, the point P and its corresponding base point B, that line will be the normal to the cycloid at the point P. Through the point P, if we draw another line which is perpendicular to the normal, we will get the tangent. So here we get the normal and the tangent, and passing through the point P, which is on the cycloid and which is 40 mm from the directing line, and hence this is the final answer.